solid state, right? The solutions. So today we are going to start the new topic, that is the solutions. So first I will write all the subtopics of this chapter. First, weightage. Generally you will get in the board pattern you will get 3 marks in the numerical part and 2 marks as a definition or any differences like positive deviation, negative deviation, all you will get. Okay, this is a weightage for the board. So what are the important subtopics are there in this chapter? First one, types of solutions. Second one, concentration units. So what are the different concentration units? Already studying class 12th, right? So mostly these chapters are finished. So what are the different concentration units? Anyone? Shruti, Preeti, Vishwanath. What are the different concentration units? First one is a mass percentage. Right? Second one is the volume percentage. Third one, molarity. Fourth one, molality. So molarity indicated with the capital M, molality indicated with the small m. Fifth one, mole fraction. Okay, that is X. And the last one more is it ppm. And seventh one, you have the normality. That is N. So these are the 7 different concentration units: mass percentage, volume percentage, molarity, molality, mole fraction, ppm, normality. So this is the second subclass. So first one will study about the types of solutions. Second one will study about the concentration units. Okay. Third one will start with the vapor pressure. Okay. So in this we'll study about the vapor pressure of liquid. Definition part. Next, vapor pressure of solutions. That is only the Raoult's law. Okay. Next, vapor pressure of the solution containing non-volatile solute. So Vp is the vapor pressure. So vapor pressure of solution containing non-volatile solute. Next, same vapor pressure of solution containing volatile solute. Next, ideal gas and non-ideal gas. Sorry, ideal solution and the non-ideal solution. So whichever the solution is obeying the Raoult's law, that is the ideal. On the whichever the solution is not obeying the Raoult's law, that is the non-ideal solutions. Next, azeotropic mixture. In this, you have again positive deviation and the negative deviation. 2 deviations are there in the non-ideal and the ideal. So again, we'll study about the Henry's law. Actually, this will be in the first only, but in the order we'll study in the last of this topic, Henry's law. So these are the third sub-classification of this chapter. Completely about the vapor pressure of the solutions, solvent, ideal gas, non-ideal gas, azeotropic mixture, Henry's law. So these are the main subtopics of this chapter. The next one is the qualitative properties. So there are total 4 qualitative properties are there. There is the RLVP, relative lowering of vapor pressure. RLVP. Next one, elevation in boiling point. Next one, depression in freezing point. Next, osmotic pressure. So these are the 4 colligative properties. RLVP, relative lowering of vapor pressure, elevation in the boiling point, depression in freezing point, osmotic pressure. So this is the section C. So in this one we'll study only about the, again, isotonic, hypertonic, and a hypotonic solutions. Okay. And the last topic of this chapter is abnormal molar masses, or the abnormal molecular masses. Either it is a molecular association or dissociation. So this is a complete overview of the chapter, what we are going to discuss in this chapter. So types of solutions is a theory part only. What are the different types of solutions are there? Okay. Again, what is the solubility of these things? This is a completely theory part. Next, numerical part will start from concentration units, mass percentage, volume percentage, molarity, mole fraction, ppm, normality. All these are the concentration units. Next, vapor pressure of liquid, vapor pressure of solutions, vapor pressure of solution containing non-volatile, vapor pressure of solution containing non-volatile solute, vapor pressure of solution containing volatile solute, ideal and the non-ideal, azeotropic mixture, Henry's law. So these are the complete topic about the vapor pressure of the solutions. After this, we have the colligative properties. There are total 4 colligative properties: RLVP, elevation in boiling point, depression in freezing point, osmotic pressure. So based upon the osmotic pressure only, we have the 3 different types of solutions: isotonic, hypertonic, and the hypotonic. And the last topic is abnormal molecular masses, either molecular association or the molecular dissociation. Okay. Any doubts in the topics?
No, sir.
What about Shruti and Vishwanath? Because this chapter is finished for you, right? Shruti and Vishwanath?
Sir?
Whether this chapter is completed for you,
Yes, sir.
then are you thorough in this chapter?
Yes, sir.
What about Vishwanath? Vishwanath, what about you? Okay, so we'll start with the starting topic. That is the types of solutions. First, what is the meaning of solution? What is the meaning of solution? Combining of solute plus solvent will form the solution, right? So combining of solute plus solvent will always form the solution. So again, what is the meaning of solubility? Anyone? What is the meaning of solubility? It is the maximum amount of solute that can be dissolved in the 100 grams of the solvent. Okay, that A. Specified temperature and pressure. So this is the solubility. So if you take solubility, again three types will be there. Completely miscible, next one immiscible, and the partially miscible. Okay, so completely miscible means what? Every portion of the solvent, the solute will dissolve. That is a completely miscible. Like if you take alcohol, or if you take the lemon juice, or the salt, if you take the common salt, it will dissolve the every portion of the water, right? So water is the solvent here, and salt is the solute. So salt is completely miscible in the given solvent, that is the water. That is the solubility. Immiscible means what? Like solute will not dissolve in the given solvent, like oil and water. So oil and water will not dissolve together at all. So that is the immiscible. Partially miscible, only little amount will be dissolved. The remaining amount will not be dissolved at all. That is the partially dissolved miscible liquids. So if you want examples for these, this ethanol in the water. If you take this one, PCl4 in water, or this one, phenol dissolved in the water. So below 70 degrees Celsius, you take phenol, it will partially dissolve in the water only. So these are the three types of solubilities. Solubility is nothing but the maximum amount of solute present in the given mass of the solvent. Right now I have taken only 100 grams of the solvent at a particular temperature and the pressure. That is only called as solubility. So based upon the solubility, we have the completely miscible, immiscible, and the partially miscible. Now, what is the solute component in the solution? Whichever is present in the lesser quantity, right? Present in small quantity. Solvent means present in larger quantity. Okay. So whichever is present in the small quantity, that is the solute, and whichever is present in the larger quantity, that is the solvent. Okay. So now based upon this solute and the solvent, total we have the 9 different types of solutions. Can anyone of you tell me what are the 9 different types? Hmm? This is a type of solution. Type of solution. Next solute. Now if you first tell me the state of the solution will depends upon what? The state of the solution will depends upon what? Shruti? The state of the solution depends upon what?
It depends on the state of solute and solvent, sir.
It does not depend upon the solute state, right? It depends only upon the solvent state. Because solvent is there in the more quantity. So whatever the state of the solvent is there, it will depends. The solution also will form the same. Okay.
Yes, sir.
So based upon the types of solutions, first we'll form the gaseous solution. Gaseous means what? The solvent is in the gaseous state. Okay, gaseous solution means the solvent is in the gaseous state. So again, we'll get the 3 different types. So first we'll take gas in gas, then liquid in gas, then solid in gas. Can anyone of you tell me what is a gas in gas example? Hmm? Just anyone of you can tell me what is a gas in gas example? Air. So liquid in gas, chloroform mixed with the H2 gas. Okay, liquid in gas is nothing but chloroform mixed with H2 gas. Solid in gas is camphor in N2 gas. Okay, that is the solid in gas. Camphor in the N2 gas. The liquid solution next. Again, 3 types. All the solid is in the liquid state. So first we'll take gas, then we'll take liquid, then we'll take solid. Now tell me any example for the gas in the liquid. Just wait for 2 minutes. I'll join you once again. Okay. So if you take the example for the gas in the liquid, it is the oxygen dissolved in the water. The liquid in the liquid is nothing but the ethanol dissolved in the water. Then solid in liquid is the glucose in the water. So up to now we have framed totally 6 different types of solutions. The next one, solid. We have the solid, then again solid, so first gas in the solid, liquid in solid, and the solid in solid. So what is the example for gas in solid? It is a H2 gas in palladium, and amalgam of mercury in sodium. That is the example for the liquid in solid, amalgam of mercury in sodium. Then solid in solid example is what? Like alloys. Copper dissolved in the gold. Or you can take any alloys also, you can take example for the solid in solid solutions. So these are the 9 different types of solutions total. So based upon the state of the solvent, the state of the solution will be decided. If the solvent is in the gaseous state, solution also will be formed in the gaseous state. If the solvent is in the liquid state, the solution also will be in the liquid. If the solvent is in the solid, the solution also will be in the solid state. So with the help of this fact, total 9 different types of solutions will be formed. Okay. So any doubts in this tabular column?
No, sir.
Are you writing the running notes or just you're listening?
Understand, sir.
Okay. So this is all about the types of solids. About the solubility we'll study afterwards, about the solubility of the liquid in the, or the solubility of the gas in the liquid, solubility of the solid in the liquids, that we'll study with the Henry's law. Okay. So next we'll study about the concentration units. So this is again the numerical part. So the first one is the mass percentage. What is the mass percentage formula? Mass of solute to mass of solution into 100. That is a mass percentage formula. Simple. Mass of the solute by mass of solution into 100 will use the mass percentage. So we'll solve one question on this. Calculate the mass percentage of benzene and the CCl4 in 22 grams of benzene is dissolved in the 122 grams of CCl4. What is the benzene formula?
C6H6.
C6H6. Carbon tetrachloride.
CCl4.
CCl.
4.
4. So in 22 grams of benzene is dissolved in 122 grams of CCl4. Find out the answer and tell me the answer. They are asking to find out the mass percentage of benzene and the CCl4 in 22 grams of benzene is dissolved in 122 grams of CCl4. Now what is the answer? Anybody got the answer? So mass percentage of benzene they are asking. So here what is the solute first? Solute is the benzene, right? Because benzene is there only 22 grams. Now solvent is what? CCl4, which is equal to 122 grams. Then overall solution is how much? 22 plus 122 equal to 144 grams. That is the solution. Fine. Now mass percentage of benzene is what formula? Mass of benzene by mass of solution. Into 100. If you want mass percentage of CCl4, what is the formula? Mass of CCl4 by mass of solution into 100. So just do this. It is equal to, what is the mass of benzene? 22. The mass of solution 144 into 100. What is the final answer? Tell me. What is the final answers? What is the answer? Tell me the answer. How much time it will take to calculate this simple one? 15.28%. This one. What about this? If you do 100 minus 15.28%, it will form 84.72%. Okay, that is the mass of CCl4. Any doubts in this problem? Any doubts in this problem? The next one is the volume percentage. It is similar to the mass percentage only, right? The units only will be different. That's equal to volume of solute by volume of solution into 100. Same what you have done in the mass percentage. The same thing we'll take here, but volume percentage we will have the units in the ml. Do you know these conversion factors, which are very important in this chapter? 1 centimeter cube equal to 1 ml. So volume, cubic volume to the ml liters conversion is important. 1 centimeter cube equal to 1 ml, or 1 decimeter cube is equal to 1 liter. Generally, if you want grams to ml, we'll take like a 1 gram equal to 1 ml only. Simple conversion. Okay, but sorry, 1 ml, right? But just will multiply with the specific or density will multiply, but density of the two substances will be same, no? So 1 gram equal to 1 ml only will take normally, but the centimeter cube to ml, decimeter cube to ml is very important conversion factor. The next one is a mole fraction. So what is a mole fraction? What is a mole fraction? Ratio of number of moles of that component by the total number of moles of all the components in the solution. Ratio of number of moles of that component by the total number of moles of all the components in the solution. Okay. Suppose I have taken the solution here. So it has a two things. One is a Na, the other one is a Nb. So Na is the component A, and Nb is the component B. So mole fraction of Xa component equal to what? Na by Na plus Nb. And mole fraction of Xb component is what? Nb by Na plus Nb. So these are the two components. So when you're adding these two, Xa plus Xb, always you'll get the mole fraction is equal to 1. So the mole fraction of the complete solution is always equal to 1. If you have the answer of XA, then mole fraction of XB equal to 1 minus of XA. Or if you want have the mole fraction of B component, if you want the A component now, subtract from 1. These are the two formulas. So this is a complete mole fraction. Whenever the problems are coming on the mole fraction, just you have to do two things. One, finding the number of moles of A component, and finding the number of moles of B component. First, tell me what is the mole formula? Mole equal to given mass by molecular mass. So mole formula is what? Given mass by molecular mass is called as in mole. So first you have to find out the component A. Next you have to find out the component B. Any doubts up to this? Any doubts? No response. Okay, just you solve one problem on this. Wait a minute. Calculate mole fraction of benzene in solution containing 30% by mass in CCl4. Calculate mole fraction of benzene in solution containing 30% by mass in CCl4. What will be the answer? First, tell me what is the meaning of 30% by mass in CCl4? If you understand this one, it will be easy for you. They said 30% by mass of benzene in CCl4. So percentage means what? With respect to 100, we have to take. Okay, that means from this statement, what we can write 30 grams of by mass, right? So 30 grams of benzene is there in 100 grams of solution. Now you tell me If you have 100 grams of solution, in that 30 is the solute, 30 grams is solute. Then what is the solvent mass? If 30 grams is a solute, what is the solvent mass? 70, right? So out of the 100, 30 grams is only the solute. Sorry, I have written solvent here. 30 grams of benzene. That is the solute. Then what can be the solvent? 70 grams, right? That is a CCl4, that is a solvent. Now, what is the given thing here? That is all our given data. So all these are the given data. So given data of benzene how much? 30 grams. And given data of CCl4 how much? 70 grams. Now, what is the formula for benzene? What is the formula of benzene? Unmute yourself and you can tell the answer. What is the formula of benzene? C6H6. What is the molecular mass? What is the molecular mass of benzene? How many know how to calculate the molecular masses? Raise your hands. How many of you know how to calculate the molecular mass? What is the carbon molar mass? 12 for the molar mass for the carbon. Total 6 carbons are there. 12 6 are. And 1 is the molar mass for the hydrogen. Total 6. So 72 plus 6. 78 grams is the molar mass of benzene. Next, CCl4. What is the molar mass or molecular mass? What is the molecular mass? 12 into 1 plus 35.5 into 4. 12 plus 35.5 into 4, how much? 142. So total mass is 154 grams. Any doubts up to this? How to calculate the molecular masses? First, unmute yourself and tell the answers. Any doubts up to this?
No, sir.
Then what is the NA value? You have to tell the answers. Already this chapter is finished for you, right? So what is the NA value here? NA is for the benzene. What is the value? what is the value of Na and what is the value of Nb? You have to tell the answer. Until you are giving the answer, so I will not tell anything. Hmm? What is the Na value and Nb value? Got the answers? Got the answer? So what is Na first? It is 30 by 78. So Nb is what? It is 70 by 154. Just you can solve these two, you'll get the answer. So Na value is 30 by 78, Nb value is 70 by 154. So 30 by 78 is 0.3846 and 70 by 154 is 0.4545 grams. Sorry, you should not take in the grams, right? Because they actually get cancelled each other. And if you want XA, that is for the benzene, equal to Na by Na plus Nb. That means 0.3846 by 0.3846 plus 0.4545. So when you solve this approximately, you will get the answer 0.458. And if you want XB, that is the X of CCl4. Just subtract this one minus 0.458. You will get, what is the answer? 1 minus 0.458? 0.532. You'll get the answer of XB. So this is a way of solving the mole fraction problems. Nothing, just first you have to find out the Na value and the Nb value. If you're able to find this Na value and the Nb value, automatically you'll get the remaining Xa and the Xb. So whenever the mole fraction problems are coming, first find the number of moles of different components. Okay, so let's end the class here with this. Remaining we'll discuss in the next class. But one thing is,